onwards, there is a small problem. Until Spark is started, I will not enjoy the course. Why? Because everything is simple, SQL and all. Now you will enjoy MapReduce. It is the easiest thing that is going to happen, but you need to know all the concepts and everything. Okay, so we will start with Hive. The material, already I have given you the three materials in the beginning in Piazza, and it is exactly the same material which we used for MongoDB, exactly the same thing that we are going to use for Hive as well. So hope you have gone through MongoDB. We have done whatever is needed in MongoDB, and the next one is Hive. Very, very important.
Which document is it? What's the document?
It's in Piazza. The first day in the email I have given you, right? It is there, right? If not, I can just put it in our normal site.
Where can I get that?
I'll give you. So, we dealt with block storage. In the modern world, there are two types of main storages that are used in the big data world. One is called block storage and another is called object store, or you always call it as S3, simple storage service. Block storage is fundamental for HDFS. Everything in Hadoop file system is implemented in terms of block storage, which is what challenged by Amazon by creating Amazon S3. In S3, everything will go into something called bucket. In block storage, everything will be divided into what you call as blocks. Block in HDFS is by default 64 MB or 128 MB. The data is divided. 3 copies are by default created. Do you really need 3 copies? If one copy is lost, you will have to retrieve the other copy, right? So do you really need 3 copies? Look at this formula. I have got A, I have got A plus B, and then I have got B, and I have got A minus B. Can't I find out A and B from these 4? Even if any one is lost, I can find out, correct? So actually, if A and B are the 2 blocks that you are storing, actually, how many blocks are needed in order to get it? Only 4. But how much Hadoop is using? For 2 blocks, how many copies will be created? 3 copies each. So total, how many are there? 6 are there, right? Waste. Actually, you don't need 6. You need only 4. This is called, just remember the name, erasure coding. This is implemented in Hadoop 3. So in Hadoop 3, you will see that it is not going to be 3 copies, but they will use parity-based mechanism or erasure coding to make sure that only minimum number is created. Okay, think about mathematics. In mathematics, you know that if there are 2 unknown variables, you need 2 minimum equations in order to find out the 2 values. You don't need 6 in order to find out the 2 values. That's the idea of erasure coding. In Hadoop 3, it is implemented. Hadoop 3 supports both this way as well as erasure coding. Erasure coding has to be explicitly managed. Don't worry about Hadoop 3 now. Right. So that is block storage. And in block storage, the data will be distributed and the data will be stored into blocks. We have seen the examples where the twinkle twinkle little star, I gave you some papers and I told you that the first block is on Mahesh, second block is on Sarita, third is on Krishna. Like that, we have created the blocks. And who creates the details about which block has gone where? The name node. The name node will contain the journal of where each block is residing, and that journal is residing in memory or in disk. It is in memory. Why? Because everybody wants to access it and they want to make it very fast. That's why it is in memory. It is written to the disk in a secondary name node, so that if the primary name node is failing, automatically it will be cached from the secondary name node. That's about Hadoop block storage. Now, in the block storage, I have got the data. So this data, I call it as twinkle. Let us take our example. This is again another twinkle, and this is, let's say, little, and this is star. 1, 2, 3 blocks. I'm not creating the copies. Assume that there are 3 copies each, so total 12 blocks. Each block, assume that these are all 128 MB blocks. Hadoop was released in 2008. Everybody started writing MapReduce programs, and the whole world wanted to use Hadoop in their applications. The most important one, who was having lots and lots of data and wanted to create analytics, was Facebook at that time. Facebook started looking for engineers to know MapReduce in a very advanced way. Not only in Java, but how to write MapReduce in Python, how to write in other languages, etc., etc. They found out that there is a problem and the talent is also very, very limited. So what they have done is they thought that this block storage, if you can express it as a table like a relational database management system in Oracle or MySQL and all, you will be querying everything in terms of tables and SQLs, right? So can we take these data which are residing in the blocks and give a hypothetical table view of this data so that anybody needs to know SQL, actually it is not SQL, call it as HQL, Hive query language, very similar to SQL, so that they don't need to know anything about MapReduce, the complexities, writing the mapper, reducer, and build and everything, right? You don't need to know all those things. So Facebook invented, created Hive, which is nothing but an abstraction or a tabular model of your HDFS. Right? So that's the background of Hive. You can see all the fundamental ideas of Hadoop there, and then from there Hive came in. It is an SQL like language, very, very, very similar to SQL. That's what you can see here. So it is an SQL like language, and it supports writing user-defined functions, format scripts, all these things we will see. You can improve the performance. I will show you how you can improve the performance. That is outside the standard Hive. I will show you by using Presto how we will improve the performance of Hive. And then it can be used for ETL. It can contain complex structures, access to different storage. What does that mean? Please remember that. Very important point. Later, if you learn Amazon S3, you will know that S3 can be exposed via Hive, so that when you query Hive at that time, actually you are querying the Amazon S3. That's what different storage. And the moment you write a query, today we will see that what is happening internally, it will create a MapReduce program for you without you writing a single line of code. So when I write select star from a particular table, what happens is internally a MapReduce program is getting generated. What all you studied in MapReduce, all the things and that and dist and then running that particular code, everything happens internally. So they made it very, very flexible. That's why Hive is called as the data warehouse component in Hadoop. What is the property of a data warehouse? It is not OLTP. What is meant by OLTP? Online transaction processing, where you are doing eventual consistency or actual consistency. Actual consistency, where you update immediately you need the data, right? That is OLTP. What about data warehouse? It is OLAP. So data warehouse is what is being provided by Hive, and that is supporting OLAP, which means that you will not be writing frequently. You will write once, but you will read many times. It is for analytics. Most of the world is using Hive for data warehouse usage, archival usage, analytics usage. That's what is happening there.
So is it a storage area or is it not a storage area?
It is not storage. Storage is,
the files.
please look at this,
The files.
the
right?
blocks.
The blocks.
Okay, and from that you are getting a tabular view. Now to give you the fundamental of any database system, if you have a database like MySQL, let's see what is the property of MySQL. So if you look here,